Hello everyone, hey there, all the techies, all the coders out there. This is yours, Innovative Coder, back again with another video. In this video is a continued session from the previous one, and in this video we'll be continuing with the code of transfer learning. So we have done till the tensors, the loading of tensors and the sorting of tensors using VStack, and now we'll be learning something that what is TensorFlow, what is transfer learning basically. So actually, in deep learning we have like quite a huge data set on which we apply the neural network, on which we apply the classification, the model which we are training, and the training time is huge. Like you increase the amount of data, and training time increases exponentially. You increase the layers in your neural network, and the training time increases exponentially in both the cases. So what transfer learning gives us freedom is that we can have a pre-trained model by the big companies, the big tech giants, or basically or any university, or if any individual has any pre-trained model, what we can do is we can have the pre-trained weights with us, and we can load them. We can apply a few layers on the top of it, basically using according to our application. We can apply the layers on the top of it, and then we can use that model to solve the purpose. And that is what we are using over here. So ResNet 50 is a model. We'll be using ResNet 50. We'll be using VGG16. We'll be using Inception, which is the model made by Google. Then we'll be using Exception, which is also another model. So what we are doing over here, we are doing something. We are assessing the dogs. For this thing, we take human files, and see if there are how much dogs are being detected in human dataset. Then we are basically what we are doing is we are like testing our previous classifier, which is the dog detector classifier, using ResNet 50. Now, after all the analysis, we are creating our own CNN classifier, our own convolutional neural network. Doing so, what we do, we take the path of the validation file and all of that stuff. We take the tensor path basically, which gives us an array of an array of the images, and then we uh, uh, typecast it as float 32. Then we divide it by 255, and here TQDM is doing its purpose of displaying the loading time and loading like all of the stuff. So it is displaying it over here. Then we use Keras to load the model, basically convolutional layer, max pooling layer, global average pooling layer. We'll be discussing about all of these things in upcoming videos. Then we have dropout, we have flatten, we have dense, and we have sequential. So basically sequential tells us that our model is sequential. Basically sequential means that our model is in a sequence, like one after the other. So here we have a convolutional layer, then we have a max pooling layer, we have a dropout of 0.2, then we have a convolutional layer, we have a max pooling layer, we have a dropout of 0.2. So it is 1 2 3 4 5 layer neural network, and we train it over here. So this is the model summary. Then we compile the model and we train the model. So this is a code I have picked from Stack Overflow, this one, because for proper visualization you need to have like all of these things. Like you need to display the epoch, you need to display how much your model has trained, and all of that stuff. So this is what we are doing it over here. So on my Mac, on my Mac CPU, I started with training it on Floyd, but eventually I thought that Mac CPU is okay for like this much training, and it took me around 1 hour 5 minutes to do this training, like 25 epochs. And the accuracy which I achieved with this model, with my own trained CNN, was 5%, which is very, very, very poor, which is pathetic. So this was my own trained model on my Mac. And then I thought of using transfer learning to achieve a better accuracy. We have some bottleneck features. We take the train, validate, and test set of all of the bottleneck features. Then we decide our model architecture. In this model architecture, what I am doing is I am using VGG16 model, which is a pre-trained model, and I take it to be sequential. So it's like we are applying we are applying two layers on the pre-trained model, so that it classifies our own like what the purpose we are going to achieve. So what we are trying to achieve is a breed detector, a dog breed detector, which is which has 133 classifications of all the breeds of dog, right? So here we are doing that thing. We take the global average pool of all of that stuff, and then we apply a dense layer with 133 classifications of our dogs, of our dog breeds. Then we have this model summary. We compile the model and we train the model. So it took me around more like 5 minutes to train this model. This was a pre-trained model, and I was getting an accuracy of 52%, which was very like 10 times better than my own model, and that was that they were far better results I found. Yep. So this was something. Then we have a predict breed function, which we'll be using at a later stage to classify the test set. Then I took another transfer learning method, which is ResNet 50, and this would be the one which was giving me a very good accuracy. So we are doing the same thing over there. The same things, like we are importing the bottleneck features. I have downloaded the bottleneck features. We are loading them, train, valid, and test set. Then again, both the two layers, global average pooling and the dense layer with 133 classifications, and the activation function as softmax. Then the model summary, same compilation, same same training. Training, it took almost like 5 minutes or 6 minutes on my Mac CPU, because Mac like has very poor GPU. So Mac CPU, it took me around 5 minutes. It can vary it can vary according to the device. Yep. So this was the thing on 25 epochs, on 20 epochs. So yep, and I was getting an accuracy of 82.6%, which is like very good, very better than the last model, which was the ResNet 50, which was the VGG16, and like multi-fold better than my own CNN, my own trained CNN. So we got an accuracy of around 82%. It can vary according to the, like, if I run this again and then predict it, then it would like the accuracy can vary. So it can vary between 79 to 83%. It was varying. Like I trained it for 4 times and I got different results every time. Now, now we use another method, which is the inception method. Inception is something is a pre-trained model by Google itself, and same method over here. We are loading the features, bottleneck features. Then we are making a sequential. Then we are adding two sequential layers. The first one is the global average pooling, and then the dense layer, which has 133 classes, and activation function as softmax. Then the model summary, compilation, and the training part. And after all of that, I was getting an accuracy of 80%, which was almost equal to ResNet 50, better than VGG16, and far way better than my own trained model. Then we had this exception model. Exception model, actually, I was not in favor of doing, but for this presentation, I did some training using exception. Actually, exception, the weights were of the weights were of the size of around like 3 GB, which took me like quite a lot of time as compared to the others to download from the internet, and to training time was actually same, like around it was 6 to 7 minutes. So it was good, so it was okay. But like we are having these exceptions. We have done something on very low, very like less sized model, and now we are doing this on a very heavy model, but still we are not getting that much difference in accuracy. So I don't think exception is very good for this particular classification. So, but that's okay, I did for this presentation purpose. Same thing we are doing, and we are getting an accuracy of 85%, which is like that's okay. Like it is 85%, it has increased a little bit, but not that much difference. Like the size of inception weights was around 1.5 1 GB, and the size of exception weights was around 3 GB, so it was like 3 times, but the accuracy difference is only 3%. So that's not a huge difference. Then we predict our breed. So I am giving it Besenji. Besenji is a dog breed, and it is predicting Besenji. So like it was quite correct. You will get to know why I'm saying quite correct. Then it does. Then we have something. Hey human, you look like what I did additionally was that if there is a dog in the in the picture, then it detects the dog, then it detects the dog breed, and if there is a human, then it says, hey human, you look like. And now what it will do is it will compare the human with all the breeds, and it will give the result of that breed which matches the most. So like to do some fun purpose, right? So it was this thing. Then this is the photo of my friend. So he looks like poodle. That's okay. And then on my photo it was giving error, like earlier. So that was something that was like I found very cool. You can find the code on my GitHub. You can go to innovative coder slash, you can go to github.com slash innovative coder slash dog transfer learning, and see the model over there. This is my GitHub account. You guys can follow me if you want, if you like the content I create. And also please subscribe me on YouTube, and follow me on Instagram. I put lots of good content over there. Thank you for this video, and have a good day ahead.